All right, so now we're going to answer part E here, which says determine the minimum additional cost of completing the project in this reduced time. So in other words, if I want to complete this thing in 15 weeks, how can I do this for the minimum amount of time, minimum amount of money possible? This is where you got to be careful. All right, so you need to start considering, and what we'll do here is we'll add another column here. Because what we want to do is consider, all right, what do I need to reduce? So reduction required. All right, so for this one right here, C and F, in order for this to occur, the reduction required was I needed to go C times 2, and I needed to go F times 2. So that overall, I was reducing it by 4, wasn't I? But hopefully you can see an issue here. And it's sometimes a bit clearer if you look at your graph. You know, if I've reduced just C and F, so let's just imagine I've just reduced C and F, will that give me the result? Remember, what you need to think is if I just apply my reductions here, my crashing here, does that create a new critical path somewhere else? And hopefully you can see that if I only was to apply these reductions, what's going to end up happening is I'm going to create a new critical path over here at 16. So if we come here for a second, what I'm saying is that if I only apply the reductions here, well, now I'm going to create a new critical path, and that new critical path will be right here. Because this will be 4 plus 4 is 8, plus 2 is 4 plus 4 is 8, plus 2 is 10, plus 6 is 16, right? So this new pathway is 16, when we know that if we crash this path, we get to 15. Now, if I want to get to 15, the most cost efficient way possible, meaning I spend the least amount of money possible, all I need to do is make sure that this pathway here is at 15. I don't have to get it to 14. 14's overkill. You know, 14, there's no point. If I want to do this for the minimum additional cost, all I need to do is I need to take this and I need to reduce it by 1, right? So in other words, I want to take this 14, and I want to just make it a 15 here. So that means I would just reduce E once. Now it says determine the minimal additional cost. So now what you have to do is like, all right, what are we doing here? I'm going to say, I'm going to go take E once, C twice, and F twice as well. And then I would come up here and figure out the cost of each of those. Now, what is it? It was $5,000. Was it $5,000 each? Yeah, $5,000 for each week. So overall, I've got I've got 5 here, 2, 4, 5. So it's going to be 5 times 5,000, which is going to be equal to 2,000. No, 25,000, isn't it? Don't mess that up. Imagine if you got all this way and you messed that up. 25,000 will be my answer. 5 times 5,000 is 25,000. And that's going to be my answer. There it is. If we look at our examiner's report here before we move on, you can see for 4D, my answer was 15 weeks. Reducing C and F by 2 weeks each reduces the length of that from 19 to 15. However, this creates a new critical path, which is 16 weeks long. This means we should reduce activity E by 1 week so that both paths are the new critical path. That 25,000 is my answer. Reduce C by 2 weeks, F by 2 weeks, and E by 1 week equals 5 weeks at $5,000 per week. Before we close up this video, what I want you to take note of is that this table method is nicely laid out with instructions up here. If we go all the way back up here, notice the last step, which says we want to find the cheapest way of reducing the possible activities so that no original path is longer than the new minimum completion time. So if we come back here, do you notice that once we had applied our reductions, what we ended up with was an original path having a bigger value than our new time there. And that's how we knew that we had to fix that issue there. So there is some, reason, some logic behind this. Of course, there is some logic behind this, and you just need to do lots and lots of practice in order to get your head around it. But hopefully this has been helpful to you, and I'll see you later.